Welcome back to my lecture series. This is Muttamiral, our Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the topic on soil erosion mapping and reservoir sedimentation that utilizes the application of RS and GIS under the subject Geographical Information System for the students of third year Agricultural Engineering. Before going into the session, let us have a small recap what we have seen in the previous classes. We have seen about data products, spatial analysis, crop acreage estimation, and also crop conditions. Today, the topic will be on understanding soil erosion, types and causes, mapping soil erosion, reservoir sedimentation, and what is going to happen if we utilize the GIS for the help of mapping them. So before going, we have to know what is soil erosion. Let us empathize ourselves that soil erosion is the process by which the topsoil is worn away by natural forces such as wind and water or by human activity including agriculture, deforestation and construction. This process removes the most fertile layer of soil, leading to reduced agricultural productivity, loss of nutrients, and can cause environmental damage. These are some of the causes of soil erosion. They are natural and human soil erosion. The natural soil erosion is usually caused due to heavy rainfall, wind, and soil erodibility. The causes done by human are made by mining, deforestation, shifting agriculture. So, in order to identify these kinds of soil erosion, initially we have to map the potential for soil erosion. So, this mapping of soil erosion is essential for preventing environmental deterioration associated with the misuse of land. By using GIS to integrate and analyze spatial data, experts can determine where surface runoff is most likely to occur, which directly impacts water movement and quality. So this could be done by integrating the erosion studies. So mapping soil erosion with GIS will be the best idea that comes under our design thinking steps. So in order to do so, initially we have to integrate the data that is responsible with help to erosion studies, which requires integrating multiple layers of spatial data, often in a cell by cell format. The cell by cell format is nothing but a raster format. This data includes information on topography and land cover and land use. This surface runoff potential is also associated because it is an attribute with each land cover and type. So the locating high risk areas plays a major role in GIS analysis. It interrelates derived data in each grid cell using mathematical models like universal soil loss equation and the revised universal soil loss equation. This analysis usually locates areas where combination of characteristics indicates high soil erosion potential. This will include areas where steep slopes combine with highly erodible and specific land cover combinations. Along with this, we have to also identify the watershed analysis where assessing erosion potential is often done throughout the entire watershed, which is the fundamental spatial unit for water resource inventory and management. So some are need to be identified under physical indicators of runoff and sediment transport. Remote sensing usually provides us the capabilities for continuous monitoring of landscape changes that impact the water quality, soil erosion, such as the formation of erosional features. So this is where the reservoir sedimentation plays a major role. As I have shown here, this reservoir sedimentation has the major impact and challenges. The sediment application dramatically reduces reservoir storage capacity, threatening water supply reliability, hydropower generation efficiency, and flood control capabilities. From the studies, we have identified there are specific capacity losses that exceeds 40% in the severely affected reservoirs. So here it has to be notified that a significant physical indicator of erosion visible through imagery is the formation of erosion gullies, and these gullies are small drainage features potentially 1 meter wide and 100 meters long that result when rainfall runoff of unconsolidated material can adequately percolate into the ground. And also, these gully indicators will help us to identify the characteristics of these runoff features which are linked to the soil material. In sand and gravel exhibit sharp V-shaped cross sections, whereas gullies in silty areas shows U-shaped cross section. Gullies in silt, clay and clay soil tends to be long with gentle rounded cross sections. And also, by mapping these erosion prone areas and monitoring the formation of gullies, water managers can prioritize interventions upstream to reduce the sediment load and also nutrient transport, which are critical components of identification of reservoir sedimentation. So let us summarize today what we have seen today. We have seen about GIS mapping and modeling of soil erosion, the definition and purposes, methodology for mapping, where the monitoring and physical indicators like data collection and integration, validate model accuracy with the help of continuous monitoring and physical indicator. The assessment question for today's session is going to be in geographical information system, what fundamental concept defines the spatial relationship between features such as adjacency and connectivity independent of their coordinates. So the options are georeferencing, map projection, topology, and rasterization. As we do know that every attribute is related to topology, so that the answer is also going to be topology. These are the references that I have prepared for soil erosion mapping. So you guys can go and search for the erosion conditions. If you guys can any doubt or anything, you guys can ping me anytime. See you at the next class. Thank you.